Hey everyone, we're going to show that our series is convergent, and then we're going to find the number of terms needed to find the sum to the indicated accuracy given here. So let's go ahead and rewrite this as the sum. And we have to be careful with this one because we're starting at n equals 0. We usually start at n equals 1. So let's just keep that in mind. So we have n equals 0 to infinity. We have negative 1 to the nth power times 1 divided by 10 to the power of n, and then times n factorial. So basically, this whole thing is your a sub n. This part right here, if we separate it out, it's going to be your b sub n. So it has to satisfy these two conditions to be convergent. And that's what we're going to do first. So for it to be convergent, we have to determine that 0 is less than or equal to, and then for this b sub, and I'm saying sub for subscript, we're going to write this as 1 divided by 10, and instead of n, you're going to write n plus 1. And then n factorial is going to be n plus 1 factorial, and that has to be less than 1 divided by 10 to the power of n times n factorial. And it is because this denominator is larger than this denominator. So it satisfies that. And then for part 2, the limit as n approaches infinity of 1 divided by 10 to the power of n times n factorial does equal 0, because as the denominator gets larger and larger, the limit gets closer to 0. So it is convergent, and we showed that by part. This was by part 2, and this was by part 1. Now, let's do the estimation part. So let's look at b sub 3. So this would be 3 number of terms. That's if we start at n equals 1, but let's just look at this right now. This would be 1 divided by 10 cubed times 3 factorial, which is approximately 0.000167, and that's greater than our desired results. So that's greater than 0.000005. Now let's look at b sub 4. That's going to be 10 to the 4th power times 3 factorial, or 4 factorial, sorry. Now that is going to equal 0.000004, which is less than 0.000005. Therefore, by the alternating series estimation theorem, since this is less than, that's not going to get to our desired result, so we're going to go to this one. However, we started at n equals 0, so our number of terms we need to add are actually n equal 4. All right, so that is the 5th term is less than the desired area. So basically this would technically be your 5th term, since we started at 0, and this would be your 4th term. Since our 5th term is less than the desired error, we need to add the first 4 terms to get to the sum to the desired accuracy. And that's it. Thank you. Have a nice day. Bye-bye.